Now, what I feel is that, like I told you, that first of all, I would like to thank all the organizing committee, Madam Sheila Mense, the coordinator of PCA Keli, Madam Jalaja Udoshi, the event coordinator, Madam Pallavi for the correspondence. Thank you. And this is the first time that we are attempting a workshop on IoT online, because whenever I have done any workshops on IoT or single board computers and all that, we always have a hands-on, because IoT is an extremely practical course. It's a very, very practical technology. I still remember that we had conducted a workshop for the students in Kaylee College, where we had given kits to the students, and then we had asked them to work on hands-on with us, gave them some examples, and then these people were doing, and they got an understanding of exactly what is the meaning of an IoT. We can have a long presentations on IoT theoretical. I can explain you for hours together, but at the end of the session, knowledge transfer will be zero, because I believe that IoT is an extremely practical course. But still, we have tried from our side here. We are going to attempt this for the first time. I have never done this before, but what we are planning to do is give you a live demonstration of how IoT works. There are a lot of boards that I will discuss with you people in this course of 2 days, and then I will be explaining to you. And then there is one thing that we are attempting for the first time, that you sitting wherever you are, you will be able to control some appliances here where I am sitting. So I will give you the access, and then you should be able to click on a button there, and then an LED or a bulb will glow here where I am sitting. Okay, something like that we're attempting to do. Let us see how well it goes. So I will immediately jump into the topic now. And then let me tell you that I will be first starting with the PPT, in which a little theoretical concepts I will explain, and then later on we will jump into the technical aspects. I will be explaining to you the boards, what type of programs you have to write, what languages you need to know. So these are some of the things that we will be doing. Let me start my PPT. Madam, you will have to give me permission to share my screen. Jalaja madam, you will have to allow me to share my screen.
Yes, sir. Permission is given, sir.
It's given now. Let me just
Yes,
check.
sir.
It is saying
I have
that
made you
host,
co-host, sir, so you can share the screen.
because when I try to share my screen, it is saying that host disabled participant screen sharing, it is saying.
Yes, sir. Can you check now, sir?
I will check it now. Yeah, now it is possible. Thank you. Okay, so I hope you are all able to see my screen here, and let me start with the first part. Yeah, this is my PPT. I'll be starting with this, and at the same time, at one point of time, I will be sharing my video also, where I'll be showing you some hardware. Okay, so at that time you can switch between my screen plus the video. Okay, so we will be doing that. Okay, so let me start with this PPT now. Like I told you, that IoT is an extremely practical technology, and first, I'm not going to spend much time. I'm not going to spend much time on the presentation. Okay, I'm just going to zoom through this, and as and when I no, I would request the participants to please mute your speakers, because there is a lot of disturbance.
sir, 1 minute. I could just interrupt. Participants, please mute your audio as well as video. Participants, it's a kind request, mute your audio.
Okay, now I think it's fine now. So I will start with the
Fine.
presentation. Like I told you people that I will be zooming through the presentations, and then as and when required, I will be explaining to you the coding part, and I will show you some demonstrations with a kit here. So IoT, Internet of Things. First, what is Internet of Things? The first definition. Okay, what we are going to cover in this content is we will see first what is the meaning of IoT and introduction to IoT. Then we will see some of the use cases of IoT. We will be looking at some of the building blocks of IoT. Then what is the meaning of a thing? What is a thing in an IoT, Internet of Things? What is an actual thing? And then what are the different types of IoT platforms available for us to develop applications? What are the challenges that are raised by IoT? And finally, an IoT architecture. This is what we'll be covering in the first part of the presentation. So what is an IoT? There are a lot of definitions on the internet. You must have seen an IoT is Internet of Things, something which you can control across the internet. You can control your television, your microwave ovens, your washing machines. A lot of definitions are there. But according to me, as a technical person, an IoT is a collection of objects or devices plus some services which will allow you to collect information, visualize data, remote control them, and smart control them. Why this definition? As an engineer, I mean, we should think, we always, whenever we learn any technology, you have to visualize to it, you have to see to it like a block diagram. I mean, what are the different blocks, the building blocks of a particular thing? So here in an IoT, it contains devices, it contains some services, and then finally, what is the output? It gives you option or capabilities to control something remotely, to control something smartly. Okay, so with this small definition, let us go further. Even if this right now doesn't make any sense, it is okay, no problem. At the end of the session, now after we come back to this slide, then you will understand, okay, fine, why did we say that it is a combination of devices plus services? Okay, right now if it doesn't make any sense, fine, but right now just remember that it is a collection of devices and services which will give you capabilities to control something remotely, to control something smartly, visualize the data, collect information and all that. Then let us see some of the use cases of IoT. Basically, use cases are the applications of IoT, where it can be applied, what I can do with an IoT and all that. Of course, it is used in smart homes today. Okay, they are used in wearables, they're used in smart cities, they're used in smart grids, they're used in connected cars, they're used in supply chains, they're used in smart farming and all that. Let me very quickly just give you two examples here. For example, okay, how is IoT used in smart homes? If I have a home, I will definitely have electrical appliances there. I will have washing machines, I will have my water geyser, I will have my microwave oven and all that. If I have a system through which I can control these devices, these appliances which are at home, which I can control them across internet, then my home is a smart home. I have appliances which are smart, which I can control from very far away. Okay, not only from some kilometers far away, but thousands of kilometers far away. You can control these devices. You can not only control these devices, you can even monitor these devices. So this is one simple application of IoT in a smart home. A lot of things are there. Then you have smart city. A lot of applications I can quote here to give you examples of how IoT can be used in smart cities. Then smart industries. Smart farming is one thing which I have practically worked on. Like while Jalaja madam was giving my introduction, she said that I floated some of the commercial products which are into farming, smart irrigation control. And this requirement just came from one of my friend who was doing his farming, and he said that it is difficult for him to get up in the night, switch on the motor to supply water to his farm and all that. Then we thought that, why can't we develop a system for him? And then by using a simple Android application, in an Android phone, we were able to control his motor from wherever he is there in the world. So this was that we had done. And this is an application of smart farming. This is an application of smart farming. Like that, IoT applications can be developed for connected cars. IoT is required in smart cities. IoT is required in industries and so on. A lot of applications in almost every domain of industry it is required. Let me tell you that in the course of this presentation of mine, there are some things which I would like to say are very important. And if there is anybody who is really extremely serious about IoT, they want to pursue their career in IoT, either in the field of teaching or in the field of freelancing or in the field of developing products or as an entrepreneur, I'll tell you that there are a few slides in these presentations which I will mark as important. Okay, so maybe you can quickly take a screenshot of that, keep a note of that, so that you can come back to it later on. A lot of things are there. Like I explained to you the previous slide where I explained about the use cases of IoT. I feel it is not very important. Anybody can tell, okay, that IoT can be used in smart homes and all that. But this particular slide, which we are right now into, the building blocks of IoT, is the most important slide here. You have to understand the building blocks of IoT. As a technical person, we are from different domains. We are teachers, we are guides, okay, and there are people who are even freelancers. Okay, for them, I will tell you this is where the actual technology starts. The building blocks of IoT, very important. What is the meaning of a building block? If I have an IoT application, if I have an IoT system, the IoT system is made up of how many blocks? Is made up of what all different things? An IoT should always contain hardware. An IoT should always contain a hardware. IoT should have some communication. IoT should have a software backend, and IoT should have an application. These are the building blocks of IoT. It should have a hardware, there should be some communication, there has to be a software backend, and there has to be an application. Finally, when I told you, we are going to demonstrate this. We are going to demonstrate this live with you people. So there you will see that each one of these blocks are implemented. We are going to write some code in each block. So I will write that code in front of you, and we are going to demonstrate this. Okay, so these are very important. We have a hardware, communication, software backend, and applications. Very, very important. And the reason why security is written here, it means that security is required at each level. At each level, if you have a hardware, the hardware should be secured. If you're doing communication, the communication should be secured. If you have a software backend, the data should be secured. And finally, the application should also be secure. So security is prime. It is important at each phase of the IoT. Okay, so these are the things that you have to understand. Let us go further and try to understand what is the meaning of a thing. IoT, the T in IoT is a thing. What is a thing? Normally people say the fridge, the refrigerator in your home is a thing. Is a thing. The microwave oven, all these things, they say they are things. Okay, but actually speaking, if let us say I have a refrigerator in my house which I have purchased some 15-20 years back. Okay, is that still a thing? No, it is not a thing. It is not smart. It doesn't have the connectivity. Now let us try to understand exactly what is a thing in IoT. By definition, it says that it is an embedded computing device that transmits and receives information over a network. Thing in IoT should possess 3 C's. It should be capable of connecting, it should be capable of computing, and it should be capable of communicating. This is important. Okay, the 3 C's in a thing is important. It should be able to connect, compute, and communicate. Let us take an example. Okay, a thing should contain these things. It should contain a sensor, it should contain a controller, and then it should contain a communication interface. Sensors will connect, the controller will compute something, okay, and finally the communication interface will be able to communicate. On a broader way, these are the blocks that are required in a thing. It should contain a sensor or an actuator. It should contain a controller definitely, and then it should contain a communication interface. We are going to explain this diagram into more detail in the subsequent slides. So I go further and take an example here. Take an example of a smart street. Take an example of a smart street light. Okay. Now you in a smart city, I've seen there are so many cities in India that has been identified to be converted into smart cities, and the first thing people do is they build smart street lights there. What are smart street lights? These street lights are those devices that are connected with sensors and they switch on and they switch off. They switch on and switch off based on the presence of natural light. Okay, so there is a sensor which is continuously checking how much is the natural light. If the natural light slowly becomes dark, then automatically it gives an instruction to the light to switch on. Okay, so this is exactly how a smart light basically works, and this has to be communicated. This information has to be communicated to the central control room somewhere. Okay, so this smart street light system should contain a sensor which will check what is the current status of the natural light. Then it should definitely contain a controller. Controller is at the heart of an IoT system. Okay, the controller basically takes input from a sensor, then takes some decisions, and then it tells the actuator to switch on the light or to switch off the light. That is what the controller does. Actuator, of course, is required for switching on and switching off the light. And finally, a communication interface is required to communicate this information to the control room somewhere. If, let us say, in our city, Belgavi, there is a control room, and they want to know how many lights are switched on right now and how many are switched off right now. So that information has to be communicated. Somebody sitting at the control room should be able to actually see that. Okay, so this is how we are comparing. So we have connect, compute, and communicate. With a real-time example here, we have a street light system which is smart, which is a part of IoT. Now let us go further. This is another important slide for all the serious developers, freelancers, teachers. A thing basically contains these things. I have developed a IoT for smart irrigation control system. Then we had developed, I will discuss with you people some of the applications that we have real-time implemented, and we have given it to industries also. So whatever things that we have developed as IoT contained these things. Okay, an IoT contains these things. The hardware contains these things. It should contain first an MCU. MCU is a controller. It's called as a microcontroller. It's specified as MCU. A microcontroller is at the heart of IoT. It is the brain of IoT. It is where the computation is done. A thing should contain a sensor. A thing should contain an actuator. What does a sensor do? A sensor senses some parameter. It is capable of measuring some parameter like temperature, humidity. There are different types of sensors available. I will be discussing about sensors in one slide in the subsequent slides. Okay, a sensor is something which is capable of sensing some parameter. That much you remember right now. Further, you will understand exactly. I will show you some of the sensors which I have here. And the next is an actuator. An actuator is something which will switch on something and switch off something which you can control. Okay, now these two things are very important in the field of IoT. A sensor and an actuator. A sensor is something which will sense for some parameter, and an actuator is something which you can control. You can switch it on and switch it off. So more or less, if you ask me what is a sensor, sensor is an input device. Why? Because it senses something and gives that as input to the microcontroller. And what is an actuator? An actuator is an output device because the microcontroller can give it instruction to switch on or switch off. Okay, so understand to it like that. Then, of course, the thing should contain a communication interface of communicating. A communication interface is required because the information needs to be put onto the cloud, or it has to be sent to Android mobile phone, or it has to be sent to some application which is running in the industry, all that. So there should be some communication interface. Now you will ask me a question. Now, what is this communication interface? What interface does it basically use? A Wi-Fi, a Bluetooth, GPRS? What type of interface it is? Now here, communication interface is any communication interface. It can either be a Bluetooth, it can either be a Wi-Fi, it can be GPRS, it can be Zigbee. It depends upon what type of application you are developing. If you are developing an application where you need to send the data to very far away distance, then in that case, a Bluetooth will not work, because you know that Bluetooth has got a limited range. It can work only within its range. It cannot go beyond that. So here, Bluetooth will not help you. In that case, you determine how much is the maximum distance it has to travel. Then if it says that it's not more than 1 kilometer, then you go for Zigbee. Zigbee is one interface for wirelessly communicating information. So in that case, the communication interface will be Zigbee. If it is not 1 kilometer, if it is something like 50 meters or 100 meters, then in that case, you go for Wi-Fi and so on. Okay, so communication interface is definitely required in a thing. Then you have a power supply. Finally, you have to power up the sensor, you have to power up the actuator, you have to power up the communication interface, and of course, you have to power up the microcontroller. So you need a power supply. Power supply is required. So a thing contains these 5 things. It contains a microcontroller, very important because that is a brain. All the inputs will be to that microcontroller only. The sensor gives input to the microcontroller, your actuator is connected to the microcontroller, communication interface is also connected to the microcontroller, and then finally you have to power it up. You have to power it up. So you give power supply to the microcontroller, and then that completely becomes one thing. That completely becomes one thing. You can pack it into a box, and then you can keep it wherever you are supposed to deploy it. Okay, so this is a complete thing. Another important slide. Next, after this, selecting the right controller. Let us say you are developing a IoT application, and you need to now select. There are so many microcontrollers available in the world. Okay, now selecting the right microcontroller is very important. Which are the parameters you consider to select the right microcontroller? First is cost. There are microcontrollers which are very, very powerful but expensive. There are some which are not so powerful, which are cheap. So depending upon your application, what it requires, you have to select a microcontroller. First parameter is cost. Second is memory. Microcontrollers come with different sizes of memory. When you write a program, your programs can be very, very big. Your programs can be very, very small. Okay, let us say you're writing a very complicated application, and there are a lot of code, there are a lot of lines of code that you want to write. And when you write a lot of code, these microcontrollers have got limited memory, unlike your computers. Computers have got a lot of memory. And of course, we will be discussing about microcontrollers in the subsequent slides. It is there, one complete thing, and it is part of the workshop. Unless and until we don't understand what is a microcontroller, there is no point going further. So one part I have kept it especially for the microcontroller. Some half an hour we will be spending for understanding what is a microcontroller. Okay, very important. That is at the core of IoT. The second parameter we consider to select a microcontroller is memory. Then finally there is power consumption. Of course, you remember this, that when you develop an IoT system, you have to keep it on 24/7, 365 days a year. You have to keep it on all the time, day and night. It is not like a laptop. Whenever I need it, I start it and then use it and then switch it off again. No, these IoT systems need to be running all the time, around the clock. So when they are running around the clock, it is important to consider how much power it consumes. And then more power consumption, you need to have a very good battery backup. Less power consumption is better for you. So finally, power consumption is another parameter that you have to consider depending upon your application. Okay, not very important. These are the parameters that you have to consider and go ahead. Okay. The other parameters that needs to be considered for constructing or for developing an IoT system is IoT communication models. IoT communication models. What is the meaning of IoT communication models? Like how you want the devices to communicate. Is it device to device? Is it device to device? Your IoT system is going to communicate from one device to another device, or it is going to be from device to the cloud, or it is going to be from the device to the gateway. Now, what is the meaning of this? I will very quickly explain to you what is the meaning of this. Okay? Device to device means it is clear that you have an IoT device, and if it is communicating with some other device, it means that these devices is at a close distance. So the communication interface here could be Bluetooth or Wi-Fi. Okay, you are not going to control anything across the internet. So device to device is not a problem. And if your system, let us say you want to develop a smart television at home, smart television in the sense you want to develop an application in your mobile phone. When you click on the in a button in your application, you want the television to switch on, and when you click on off, it should switch on. Okay, and of course you will be sitting in the room only to switch off and switch on a television because you want to watch it. Okay, we are too lazy to go get up and switch on the television, so we want to sit at the corner or on the couch, and then we want to click on a button. We want the television to start. We have a remote, of course, for that, but we want to make the television more smart, so we are developing an Android application for that. So if that is a scenario where you want to control something within very small distances, then the communication model you should use is a device-to-device communication model. Then device to cloud. Now let us say I'm going to discuss with one of the case studies with you people. Okay, we will come to that, and I will even demonstrate that to you people. Device to cloud is the device is directly connected to the internet. Now for this, the device should be having a global IP address. It is important that the device should have a global IP address. In that case, only the device will be able to communicate to the cloud directly. Okay. Now the next is device to gateway. What is the meaning of device to gateway? Let me give you an example. I had downloaded one article somewhere back, and then yeah, this is what it displayed. Here there is some fact. It is written that there are approximately 400 million street lights in India. We have 400 million street lights in India, which means that if I want to go for this model here, device to cloud model, each device is connected to the cloud, then only for this particular application, I need 400 million IP addresses. It's not feasible. Only for this. Of course, I have a lot of IP addresses. I definitely have more than 400 million IP addresses. But giving or assigning 400 million IP addresses only for one such application is not feasible at all. But there are some applications where devices needs to be directly connected to the internet. We will be showing you one such example. So this is the communication model. Finally, after you have decided that you want to develop an IoT application or IoT system, you have to first take a decision over this. What communication model I'm going to use? Is it going to be a device to device? Is it going to be a device to cloud directly? Or is it going to be a device to gateway? Now, what is the meaning of this gateway? Gateway is something which is connected to the cloud directly. So a gateway has got one IP address. There are multiple devices in a campus. So multiple devices gets connected to the gateway. These individual devices in the campus need not have individual IP addresses. They all have local IP addresses. They directly get connected to the gateway, and the gateway gets connected to the cloud. Okay, so in a campus, if there are, let us say, 10 devices, the 10 devices need not have global IP addresses. They need to have only local IP addresses, which are available in abundant quantity, no problem. And these devices get connected to the gateway in the campus, and the gateway now sends that data to the cloud server. Right now, even if this doesn't make any sense to you people, it is still okay, no problem, don't worry much about this. This is too much into core of IoT. But remember that there are communication models where I can have a solution where one device is communicating with another device. One device is communicating directly to the cloud. For this, I need what? A global IP for each device. And lastly, we have device to gateway, where devices get connected to the gateway, and the gateway in turn sends the information to the cloud. Next, once we have decided upon the communication model, then you decide upon the protocol. There are different types of protocols available. Okay, for the communication, for the wireless communication, what protocol you want to use? Do you want to use Bluetooth, Zigbee, Wi-Fi, cellular, or NFC? Bluetooth, you know, you can communicate only from 50 to 150 meters. Zigbee, you can communicate actually from 10 to 100 meters. Even I have heard about some Zigbee antennas or Zigbee transmitters and receivers which can communicate across even 1 kilometer also. Then you have Wi-Fi for 50 meters, no problem. Then you have cellular. Cellular again, can communicate from 30 kilometers to 200 kilometers. And if it is on GPRS, if it is on the internet, then there is no limit on. Of course, there is no limit on the distance. I can control something sitting here in India, which is there in the US, which is almost on the other side of the globe. I can control using this network. Okay, and finally, there is something called as NFC, near field communication, which is having a range of only 10 centimeters. So these are the protocols. Finally, it is up to us to decide which protocol we are going to use. Okay, don't worry much about this slide right now. Next, which are the different types of platforms available for us? Which are the different platforms available for us for developing these? I will tell you that there are numerous big players who have jumped into this IoT recently, and they are providing platforms for developers like you and me for using their platform to develop applications and deploy it on their platform. Okay, they are providing this. You also must have heard about a few of the platforms. Okay, Microsoft has got Microsoft Azure, then Armbed is there, then Amazon, AWS is there, Amazon's Web Services, which will provide you platform to develop your IoT solutions and deploy it on their platform. Okay, and then finally you have Huawei, then you have Cloud of Things. So many are there. Okay, so many are there. These are few important players in the market who provide you frameworks or platforms to deploy your IoT. I am sure here, first of all, the question that I should have answered is that what are these platforms? What do Amazon Web Services provide us? Finally, remember that these players provide us a little space on the cloud so that we can store our data there. These players also manufacture some hardware, they give it to us, and they ask us to use those hardware. It is easy for these hardware to directly connect to our cloud server, and then you will be able to control. The devices across the globe, wherever you are remotely. They provide this. So these players or these companies basically provide you interfaces to communicate across the cloud, use the hardware, use the sensors, use their actuators, develop applications. And initially they gave it for free, almost negligible price. But you never know, in the future what may happen is, once people start using their platforms, they may start charging for it. Like how Google started with the Google Translate. Initially it was free, then later on they started charging for each translation. Okay, so something like that they can do. So the best way is to know about these platforms, but to come up with your own platform, which is easy. What I'm going to explain to you in the course of this is to create your own platform. Don't worry much about these third-party or off-the-shelf players who provide you a platform to develop your IoT applications. The best is to develop your own platform, right from the hardware till the user application. And this is the process that we are going to explain to you in this course of thing. Very quickly, but okay, we are going to explain to you this very quickly. And the advantage of having your own platform is that it's completely flexible. You can do whatever you want. It is your own platform, it is your own code. You do changes wherever you want. But if you are using any of such standard frameworks and platforms, it becomes difficult. Okay? You have to use their formats only. You have to use their hardware only, and all that. A lot of problems using standard frameworks like this. Okay, but to start with, people actually go for this type of platforms, and then later on they go for customize their own platforms. Let us go further and see some of the famous or most popular platforms. We have AWS, Amazon's Web Services, then we have Microsoft Azure, then you have Cloud, Google Cloud IoT. These are some of the players, okay, and then these are some comparisons. As far as security is concerned, all of them provide security, data analysis, they all provide. The protocols which they use is HTTP, MQTT, and so on. Okay, so this is a little comparison. Of course, this had to be a part of the slide, so I put it. Okay, but then normally developers like you and me, we don't look into what are the features provided by most of the. Finally we have to go for a custom and self-made platforms instead of going for this. Okay, so this is the comparison of AWS, Microsoft Azure, Google Cloud IoT. And then there are two more very important IoT platforms available in the market. One is IBM Watson, and next one is Oracle IoT, and next one is Oracle IoT. Okay, so these are the major players. Let us go further and see what are the issues, challenges raised by IoT. We are at the end of the first part. I will be starting with the second part, which is going to be more interesting. We are going to go for the next part, which is the second part, which is going to be more interesting. Okay, let me just check if I'm also muted here. So the issues raised by IoT, first is security. Security is very important. Finally, after you have developed an IoT system, is it secure? Is it secure? That's the first question that is asked. Okay, providing security to your IoT systems is extremely, extremely important. Okay, next is privacy. Will it maintain your privacy? If let us say, you are keeping a lot of data into your database, is it private? Have you made it public on the cloud? Finally, then there is something called as interoperability and standards. This is one of the biggest challenges that is faced by developers today. Let us say I design my IoT platform today, I start using it. I use some available hardware from the market. I develop the entire system. I deploy it. People are using it. Finally, tomorrow, let us say I want to develop one more sensor node and I want to put it into this existing system. Now, the new system which I develop, I use a different hardware for it. Is it interoperable? Can it be easily plugged into the already existing system? Almost every day, there is a new hardware that is getting introduced in the market. If I develop my new hardware, will I be able to directly plug it into the existing system? Or do I have to follow some standards? So that is another problem that we are facing in designing IoT applications. And then finally, legal, regulatory and rights, like if I develop an IoT application, if I want to control something wirelessly by sitting here across a distance of 30 kilometers or 40 kilometers, will the local government rules, regulations allow me to do it? Is it legal to do it? For example, I can develop a drone, okay, and I can control it by sitting here. I can just click on the drone and the drone can fly from where I am sitting, can travel to a place somewhere else. It's not that safe. People can do anything with that technology. So is it legal, first of all? When you're developing an IoT application, is it legal? Is it allowed by the government? These are some of the challenges that has to be faced by developers, whoever does IoT system development. This is the end of part one, theoretical completely. Now, I will immediately jump into the second part, where we will be understanding the architecture of IoT, and then in this second part here, we have demonstrations. Okay, so we are going to check the second part. So what we have here is the second part of IoT, and what we are going to discuss in the second part of IoT, we are going to discuss a simple IoT architecture first. Then we are going to check the building blocks of IoT. Like I told you, the first slide, which was important, the 4 building blocks of IoT. Contains what? Hardware, communication, software backend, and application interface. So we are going to develop these individually. We are going to write code for developing this individually, and then we are going to demonstrate this to you. Okay, so first we will understand what is a simple architecture of an IoT. This is a simple IoT architecture. Simple IoT architecture. And of course, if you look at this, this simple architecture of the IoT contains the 4 building blocks of IoT. The first building block of IoT was hardware, if you remember. The second was a controller. Sorry, the second one was in communication. Third one was a software backend, and the last one was application. So if you take this, if you consider this, okay, if you consider this sensor and controller, this is the hardware part of your IoT. It contains a controller, the brain of the IoT. It contains a lot of sensors. It can contain temperature sensor, humidity sensor, pressure, motion, and then it can contain even the light sensor. So this entire thing, these 2 blocks here, is the hardware of your IoT architecture. Then you have something called as the IoT framework and the gateway. Now this is the communication block of your IoT. The communication block of your IoT. Then you have the cloud server, in which you have the software backend of your IoT. The cloud server, which is the software backend of your IoT. And finally, the mobile application, which is the application part of your IoT. So these are the 4 building blocks of IoT, which I told you. And in the architecture, this is how they are represented. I have the hardware here, which contains a lot of sensors, actuators, the controller, which is the brain. It contains a gateway here for communication. It contains a software backend in the cloud, and then finally an application for the user to see what is happening. So the user on the mobile phone here will be able to actually visualize the data that is being collected by the sensors, or the user will be able to control something. I click on a button here on the mobile phone and something should happen here on the hardware. So an interface, an application, either as an Android app or a web-based web page, has to be provided for the user to interact with the IoT system. So 4 blocks. 4 blocks we have. Let us go further. IoT hardware. What does an IoT hardware contain? IoT hardware contains sensors, actuators, microcontrollers. It can even contain single board computers and wireless communication capabilities. Okay, it can contain wireless communication capabilities. Now here you will get confused. A new word is introduced. What is a single board computer? Okay, I never mentioned about this before. A single board computer or a microcontroller. Your IoT system can contain either a microcontroller or a single board computer. If your application is small, no much things to be done, you go for a microcontroller. But if, let us say, your application is complicated, it's complex, it has to perform a lot of things, a lot of computation, then you go for a single board computer. So in your IoT system, the brain can either be a simple microcontroller or it can be a single board computer. So how do you decide what to go for? It depends upon the application. If it is simple, not much computation, you go for a microcontroller. If it is complicated in terms of doing a lot of computation, then you go for a single board computer. Microcontrollers are available in the market, numerous of them. Okay, all the way from simple microcontrollers, which you will get it for 40, 50 rupees also, till microcontrollers like ARM, which are expensive. You get it in the range of 1,000, 1,500 rupees. Single board computers are, of course, expensive. Single board computers are in the range of 2,500 to 5,000, 6,000 rupees also. So of course you would want to make your application, your IoT system economical. So you would unnecessarily don't want to go for single board computers unless it is required. Okay, so we will understand microcontrollers and single board computers in more detail in the subsequent slides. I will immediately give you some examples of microcontrollers. Microcontrollers, you have Atmel, you have Atmega, you have PIC microcontroller, then you have the MSP. So many are available, okay? But the one which we are going to use is going to be Atmega 328P, okay? That is a serial number. You don't have to remember it, don't worry. Okay, so we have microcontrollers, a lot of them. Then single board computers examples, if you want to give me, then of course there is the first name that comes to my mind is the Raspberry Pi. Then you have a Panda board. Then you have the Beagle board. A lot of single board computers are now mushrooming. Okay, in off late, I saw that a lot of people are coming up with their own single board computer, and I will explain to you what is the meaning of a single board computer. I think this is there in the tomorrow session. So we have what should an IoT hardware contain? It should contain sensors, it should contain actuators, it should contain either a microcontroller or it should contain a single board computer. And finally, it should definitely contain a wireless communication capability. Okay, let us go further. What is a sensor? What is a sensor? Sensors, I told you by the definition, is something which is capable of sensing some parameter. It is capable of measuring some parameter. A lot of sensors are there. We have this ultrasonic sensor here. Okay, this ultrasonic sensor is there. What do we do using an ultrasonic sensor? Ultrasonic sensor directly needs to be connected to the microcontroller, and then what it does is it will detect obstacles, and it can even tell you what is the distance of this obstacle, how far this obstacle is. It can even tell you that. Then you have a gas sensor, of course. A gas sensor is used for detecting the presence of gas. If there is presence of gas around it, then it will know it, and then it can inform that to the microcontroller. Then you have a color sensor, which will sense color, and then sense color in the sense you keep any fruit and just place the sensor above that, and then the sensor can tell you, okay, what color is that fruit. It gives you info. It doesn't give you directly the color, okay, of course. It will give you some value which you have to calibrate and then convert that into a color. All that. Okay, let us not get into the individual working of the sensors. I will just very quickly explain to you. Ultrasonic sensor, I told you it is for distance. Gas sensor for detecting gas. Color sensor to detect color. Then you have a PIR sensor. PIR sensor is used for detecting motion in your room. For safety, security, people use that. Then you have an accelerometer, which will tell you, the x-axis and the y-axis of how much it is tilted and all that. For example, in your mobile phone, you have that feature. If you hold your mobile phone straight, then it knows that it is straight, so orientation automatically changes. When you hold it, lengthwise, horizontal, then it knows that it is mounted horizontally, and then the orientation automatically changes in the mobile phone, because your mobile phone contains an accelerometer. Then you have a potentiometer for increasing and decreasing the resistors. Then you have an IR sensor for obstacles. Then you have a flex sensor to detect how much force is applied on that strip there. Then you have an LDR, light dependent resistor, to check if there is presence of light. For smart lights, we use this sensor, by the way. Then you have a thermistor, of course, another sensor which will help you to detect what is the temperature around you, and so on. Okay, and then you have the rain sensor to detect if it is raining outside. Of course, not to measure how much it is raining, but whether water is falling on it or not, that is what it checks. And there are so many numerous here. Okay, there is an IR sensor, then you have a Hall effect sensor for checking magnetic field around it, and so on. So there are numerous sensors available. It depends upon what application you are writing. You have to select appropriate sensor and develop an application for that. Okay. And then, of course, there is a link here. If I click on that, it will open a image in which there are more sensors there, but I feel it is not required right now. So I go further and then explain to you people what is the meaning of an actuator. Okay, finally, let me just remind you people that we are understanding the first block of IoT architecture. IoT building blocks, 4 are there: hardware, you have the communication, you have software backend, and then you have application. 4. So we are discussing the first block of IoT, that is hardware. What does the hardware contain? It contains sensors, actuators, microcontrollers, okay, and communication. So we understood first what is the meaning of a sensor here. In the next slide, we will be understanding what is the meaning of an actuator. I told you that a sensor is something which will detect for a parameter. It is capable of measuring some parameter like temperature, humidity, moisture, presence of gas, distance, obstacle, and all that. On the other hand, an actuator is something which you can control. You supply it power, you supply it power, it starts rotating, or it starts doing something. Okay, some of the examples of actuators are a DC motor, of course. You know what is a DC motor? A DC motor is something which will have two terminals. If you connect it power supply, it will start rotating. On the other hand, then you also have another actuator which is called as a solenoid. A solenoid is something which will have two terminals. You supply it power, it automatically either opens the valve or it closes the valve. And finally, one more example of an actuator which is here is a relay. A relay, of course, again has two terminals. You supply it power, then it switches on something. It switches on something. And why do we use a relay? We use a relay for controlling big machineries. Right now, understand only that much. Okay, don't go into the detail of understanding what is a relay. There is a separate presentation for understanding what is a relay. But right now, just imagine that a relay is nothing but a switch. It's a switch which can be controlled by a microcontroller to switch on and switch off big machineries which require a lot of power. Okay, so an actuator is something which you can control. Give it power, you can switch it on. Don't give it power, it will switch it off. Okay, so we have DC motors, we have solenoid valves, we have relays. These are only some examples of actuators. Next, the main and the most important topic is a microcontroller. Okay, what is a microcontroller? A microcontroller, I'll first read out what is written here on the slides, and then I will explain to you my concept of a microcontroller, in the sense like how I have understood a microcontroller. It's a single tasking electronic device. Okay, all the serious coders here, all the serious teachers, all serious people who want to venture into entrepreneurship, freelancing, please be attentive here. What is a microcontroller? A microcontroller, it's a single tasking electronic device. It has GPIO pins to connect sensors and actuators. The photo here, which is given on the top here, is an example of a microcontroller. You will see that this is nothing more than IC, you will say. It's an integrated chip. It has got some pins. Is this in a microcontroller? Yes, of course, this is how a microcontroller will look like. They come in different sizes and shapes. Okay, but this is an example of a simple microcontroller. It contains GPIO pins. What is GPIO? General Purpose Input Output pins. The pins that you see here, some of them are GPIO pins. Not all the pins, but some of them are GPIO pins. What are these GPIO pins? GPIO pins are those pins to which you can connect your sensors and actuators. I can take a gas sensor, and then I can connect it to one of the pins here. I can take a DC motor, then I can connect it to one of the pins here. Okay, finally, why do we have to connect this? I will explain to you that later on. So an electronic device, which is a single tasking device, which has GPIO pins, to which you can connect sensors and actuators, is a microcontroller. What do you mean by a single tasking electronic device? A microcontroller, remember, that is a device which is capable of running some program. A microcontroller is a device which is capable of running some program. A microcontroller contains ALU. A microcontroller contains ALU. We all know what is ALU, arithmetic and the logical unit. It is a unit which is capable of running some program. You can write a program and the ALU can execute that program. Now, the first thing that will come to your mind is that, yeah, this program is written using which programming language? Okay, normally a microcontroller understands only hex language. Hex language. So then you will ask me the next question. So then in that case, do we have to write the program in hex language? We don't know this programming language. No. You don't have to write hex programs. You have to write your programs in C only. Then we use an intermediate software which will convert our C program into hex code, and then we put this hex code into the microcontroller. Okay, and then the ALU understands hex code and then it executes that. This is for your information. So what did I tell you? I told you that a microcontroller is an electronic device which is capable of running code written in hex. We don't have to write hex code. We write programs in C. This C program is converted into hex code by an intermediate program. There is a software available. I will show you that software. So we give C program as input to that program. It converts it into hex code, and then we put that into the microcontroller, and the microcontroller will start executing that code. Why it is called as a single tasking electronic device? It is called as a single tasking electronic device because this microcontroller can run only one program at a time. You can in fact store only one program. can in fact store only one program into the microcontroller. You cannot store two programs into the microcontroller. Your microcontroller has memory in which you store the program, and at any given time, you can store only one program into the microcontroller. Then you will say, then can we store more programs? In the sense, I want to write a new program into the microcontroller. Of course, you can write a new program into the microcontroller, but remember that when you write the new program into the microcontroller, the previous program will get erased. This is the reason why it is called as a single tasking electronic device. At any given time, only one program. And program in a microcontroller terminology is called as a task. A program that we write into the microcontroller is called as a task. It can perform only one task at a time. So let me just quickly read this out once again and then proceed. Single tasking electronic device having GPIO pins to connect sensors and actuators. Next, it is used for developing embedded systems for home and industry automation. Okay, we use this microcontroller to develop some automation into the industry. I will give you some case studies where we have used microcontrollers to develop automation into cashew industries. Some of the examples of the microcontroller. Now you will ask me a question like how many microcontrollers are available, which are the most commonly used microcontrollers. The first microcontroller was 8051. 8051 was the first microcontroller. Then ATmega is something which was introduced into Arduino. It was there before that. Then we have the PIC microcontroller. Then we have MSP. Then we have ARM, etc. There are a lot. Okay, I have mentioned only few here. I have mentioned only few. But the most commonly used microcontrollers are, I will tell you, the PIC microcontroller, of course, the 8051 microcontroller. Then we have the PIC microcontroller. Then we have MSP, ARM, and this also completely depends upon your requirement. If let us say my requirement is not much, very simple application I want to develop, then I go for 8051 based microcontroller. If it is real time, then I go for PIC. Industries, they use PIC. Then you have ARM processors for doing much more powerful, has got a lot of GPIO pins and all that. Okay, let us go further. Yeah, this is important. Very, very important for all the serious coders here. How does a microcontroller work? Take this as an example. Okay, now what we have here is a microcontroller. This microcontroller here, okay, has got 8 pins. 1, 2, 3, 4, and then 5, 6, 7, 8. You can see even the pin numbers here. Okay, when I buy a microcontroller from the market, they will tell me that, boss, you are buying this microcontroller, pin number 1, you have to always connect plus 5 volt here. Then to pin number 5, you have to connect ground or the negative of the power supply. Okay. The microcontroller is a computing device which contains memory, which contains an ALU, and it contains GPIO pins. When I purchase a microcontroller from the market, they will tell me that pin number 1 should be connected to plus 5 volt and the ground is pin number 5. So I take a power supply. What I have here is a power supply. I take the positive of the power supply, connect it to pin number 1. I take the negative of the power supply, connect it to the ground. The moment I do that, you know what will happen? If I take the positive of the power supply, connect it to pin number 1, negative of the power supply, I connect it to the ground. Whatever program is written into the memory of the microcontroller will immediately pick it up and it will start executing it. The microcontrollers are designed in that way. Microcontrollers are actually designed in that way that the moment you supply it power, the moment you give it power, plus 5 volt to pin number 1, ground, pin number 5 to negative of the power supply, whatever program is inside the memory of the microcontroller will give it to the ALU and the ALU will start executing it. This is how it is designed. All microcontrollers for that matter. Okay, now take this example here. Take this example. Okay, take this example here. What I have done is I have a power supply of 5 volt. Positive, I have connected it to pin number 1. So I have supplied it plus 5 volt. And the negative, I have connected it to pin number 5. You can see I've connected the negative from here, it goes, and then it gets connected here to the ground pin. And then the positive from here, it goes and it gets connected to the pin number 1. Okay, so now the microcontroller has got power and the program that is written inside it will start executing. Now we are going to write the first program. Normally people write this program only, okay, when they start working with the microcontroller. This is called as the blinky program. We blink an LED. See how we blink an LED. What we do is I take an LED here. Okay, I take an LED here and I take the positive leg of the LED and I connect it to pin number 8. I take the positive leg of the LED and I connect it to pin number 8. The negative of the LED, I connect it to the ground, the negative, ground, okay? What you need to switch on the LED? What you need to switch on the LED? You need plus 5 volt. You need to supply plus 5 volt to the positive leg, and the negative leg of the LED you should connect it to the ground. Then you will find that the LED is glowing. You will find that the LED will start glowing. Okay. Let me take an eraser. Okay. So I have this LED here. I've connected the positive of the LED to pin number 8 and the negative of the LED to the ground. And now I'm writing a program into the microcontroller. Now let us assume that I'm writing a program in the microcontroller, and this is the program that I'm writing into the microcontroller. It's a C program. Everybody will understand. It's a simple syntax, more or less like C syntax. I have function main here. In the function main, then there is some initialization. Why do we need to do initialization? We have to tell the microcontroller which pin you are using it for what. Now, I have connected my LED. I have connected my LED to pin number 8. So I will be controlling this pin. I will be controlling this pin number 8. I will be putting a plus 5 volt on that pin. I will be putting a 0 volt on that pin. So since the microcontroller is going to control the voltage on this pin, the microcontroller is going to use that as an output pin. I initialize P8. P8 is nothing but pin number 8. I initialize it as output pin. Why am I initializing it as an output? Because I am going to control it. If let us say this LED would be a sensor. This LED would be a sensor. It is sensing something from the external parameters. And then it is giving that as an input to the pin. In that case, if you connect a sensor to a GPIO pin, you use that pin as an input pin. This is important. In a microcontroller, GPIO pins can either be used as output pins or as input pins. If you are controlling the voltage through your program, if you are controlling the voltage on that pin, you have to use that pin as an output pin. But if you have connected a sensor to that pin, you are using that pin as an input pin. Okay, so that's now what I'm planning to do is I'm planning to control the blinking of this LED. So I use 8 as an output pin. How to use that? I simply say init P8 comma output. Don't understand the syntax here. Don't please by heart the syntax. The syntax is actually not correct. We are going to learn a different syntax in the subsequent slides. So I initialize pin number 8 as an output pin. Then I take a while loop. While 1, you all know what is the meaning of while 1. While 1 is it's an infinite loop. It continuously executes forever. Okay, so there is no condition to stop it. So I go into an infinite loop. What I do P8 is equals to high. In the field of electronics, high represents plus 5 volts. High represents plus 5 volt. Remember, what I do is I write P8 is equals to high, which means that I am telling the microcontroller to put a high signal on pin number 8. I'm telling the microcontroller to put a high signal on pin number 8. And then there is a delay of 1 second, 1000 milliseconds, which is equal to 1 second. So there is a delay of 1 second. So for 1 second on pin number 8, there will be plus 5 volt. As long as there is plus 5 volt on pin number 8, the LED has got power and it will glow. So for 1 second, it is glowing. Then immediately after the delay, I am doing this. P8 is equals to low. I am doing P8 is equals to low. What does that mean? Low in electronics means 0 volts. Low in electronics means 0 volt. So I'm putting 0 volt on pin number 8. So when I put a 0 volt on pin number 8, the LED will not get current, it will not get voltage, no power, so it will switch off. And then it will remain switch off for 1 second. And then I again go back. I again go back to the while loop because it is an infinite loop. Again, I put a plus 5 volt on pin number 8, cause a delay of 1 second, and then again make it low, switch off the LED, again wait for 1 second, and then continue doing this. So as long as the microcontroller is powered up, you will see that the LED is glowing for 1 second, and then it is off for the next second. Again, it glows for 1 second, and then again it is off for the next. I hope this is clear. I hope this is absolutely clear. Okay. Now at this point, I would like to ask if there is anybody who wants to ask some question. Okay, this is important because your entire IoT concept, what is happening in the world today in the field of IoT depends upon this understanding. You have to understand the concept of high signal, low signal, the concept of microcontroller, Okay, so I feel that this is an important slide where everybody should understand something. This is important that we have pins here, GPIO pins, to which we can connect LEDs. I have one more slide after this in which I'm going to explain to you one more program, and then finally we will see a demonstration. I will show you a demonstration live on the camera. So what we have here is a program which will cause an LED which is connected to pin number 8 to blink for 1 second. 1 second blink rate is there. It will be on for 1 second, off for 1 second, on for 1 second, off for 1 second. So as long as you are connected it power supply, that blink, the LED will blink forever. Let us take another example. Okay, I will explain that example and then we will wait for questions. Okay, we'll go for another example. This is another example. This is another example. Here, what I have is, instead of an LED, I have a buzzer. A buzzer is something which will start making a buzzing sound. It will make a sound. Okay, it will start beeping. A buzzer, when it is supplied plus 5 volt, it will start beeping. It will make some sound. Now, instead of a LED, which I was blinking in the previous example, I have connected a buzzer here. The buzzer is connected to pin number 8, remember, and if I supply plus 5 volt on pin number 8, the buzzer will get power and it will start making noise. Okay, if I put a 0 watt on pin number 8, it will stop. Okay, simple. I just replaced my LED with a buzzer. LED will glow, buzzer will make sound. I have also connected one extra thing to pin number 2. I have connected a gas sensor. You can see there is a gas sensor here. That I have connected to pin number 2. I will tell you how does a gas sensor work. A gas sensor works in a very simple fashion. What will it do is, there is an output pin of the gas sensor. That output pin of the gas sensor, I will connect it to pin number 2. If there is presence of gas around the gas sensor, if there is presence of gas around the gas sensor, the output pin will be high. The output pin will be high. Okay, there will be plus 5 volt. There will be plus 5 volt in the output pin of the sensor. The sensor, okay, this pin that I've connected from the sensor to pin number 2 here, remember, it is the output pin. And when will it be high? When will the voltage on that pin be plus 5 volt? If there is presence of gas around it. If there is no presence of gas around it, if there is no gas around it, then the output pin will contain 0 volts. You understood now? If you understand how the gas sensor works, it is a sensor, okay, which you have to place it in somewhere, and if there is presence of gas around it, the output pin will contain 5 volts. If there is no gas present around it, it will be 0 volts. Okay, and that I have connected it to pin number 2. Okay, simple. Buzzer to pin number 8, gas sensor to pin number 2. So pin number 2 is being used as input pin because the input is coming from the sensor, and pin number 8 is being used as output pin because I'm controlling the buzzer through it. Okay, let us go to the program now. Very simple program. First of all, initialize the pins. I'm using pin number 2 as input because I've connected my sensor there. I've connected pin number 8 as output because I've connected my buzzer there. Fine, my initialization is over. Then I go into the while loop. I go into an infinite loop. Look at this program. If P2 is equals to high, then P8 is equals to high. When will be P2 high? P2 will be high only if there is gas present around it. If there is gas present around the gas sensor, P2 will be high, of course, because the output pin of the sensor will be plus 5 volt, and P2 pin will be high only when there is gas present around the gas sensor. If P2 is high, then put a high signal on pin number 8. What is connected to pin number 8? Buzzer is connected. So this part of the program does what? If gas is present, the buzzer will be on. If gas is present, the buzzer will be on. If P2 is not equals to high, the else block will get executed. In that case, I'm putting a low signal on pin number 8, which will switch off the buzzer. Just look at this, how simple this thing is. By writing only 4 lines of code, by using a simple microcontroller, by using a gas sensor and a buzzer, we can develop a safety system. Connect a buzzer to pin number 8, connect the gas sensor to pin number 2, write this 4-5 lines of code, put it into the microcontroller, buy a microcontroller for 50 rupees, take a power supply of 30 rupees, a buzzer of 5 rupees, a gas sensor, a little expensive it is, 125 rupees. You can put everything into one small box and we can keep it into our kitchen. If there is leakage of gas, LPG, then it will start picking buzzer. A simple safety system using only 4 lines of code. So this is a different case study. Similarly, I can use the same for some other application in the industries. I can use a different sensor here, a different actuator here to control something else. But this is a real-time safety system using a simple gas sensor and a cheap buzzer with a simple microcontroller. I hope this is clear. Okay, I told you this is important. I want everybody to please understand this so that we can go further. We have another 45 minutes left. We can have a small demonstration. Okay, and then for tomorrow's class, I will tell you what we will be doing in the tomorrow's class. Immediately after this, we are going to do a little bit of Arduino and then a demonstration. Okay, I hope this is clear, all of you. This is where I stop explaining to you people what is the meaning of a microcontroller. Don't worry much about what code we are going to write and all that. I will be explaining the code also. Okay, let us go further and see what is an Arduino. What is an Arduino? Okay, I'll stop here. Let me see if there are any questions coming up. Or you can just chat and say, sir, please continue so that I can move ahead. Yeah, there is a question here. Yeah, madam, on behalf of somebody is asking a question here. Does all controllers use the same syntax? Yeah, it's a good question. Does all microcontrollers use the same syntax? Good question. Actually, the question that is being asked is that I have written some syntax here. I've written some programs here. If let us say this is the PIC microcontroller, do I have to write the same program? If it is at a mega microcontroller, do I have to write the same program? Please remember the program that I have written here, this program is not the syntax. This is not the syntax in any microcontroller. This is only to explain to you the logic of the program. Syntax is different. I will be writing the syntax. For example, right here, I said P8 is equals to high. What is the meaning of P8 is equals to high? I'm putting a high signal on pin number 8. But in Arduino or in any microcontroller, we don't write like this. We don't write P8 is equals to high. We don't write like this. There is a special syntax for that. We write digital write pin number 8, comma high. That is a syntax to write that. This is only the logic of the program. If you want to write this program onto the ARM board, logic is same. Arduino board, logic is same. PIC board, logic is same. Syntax in different microcontrollers are different, of course. They're different. Some of the microcontrollers support even Python, so you have to write your program in Python. Some of the microcontrollers support embedded C, so you have to write embedded C programs there. Okay, and so on. So syntax is different for different microcontrollers. This what I wrote here is only the logic. Okay, in fact, the syntax is much more simpler than the logic here. The logic that I've explained is a little too complicated. But if I tell you the actual program, it's much more simpler than this. Can you proceed? There is another question. Is the gas sensor works for any gas? Yeah, now another question madam is asking here is that the gas sensor that I was mentioning about, will it detect any type of a gas? No, madam, different gases have got different sensors. Okay, CO2 is carbon monoxide. Okay, no, CO, carbon monoxide, CO. For carbon monoxide, we have a different sensor, MQ2, it is called as MQ2. Then we have one more sensor called as MQ6, which will detect LPG sensor, LPG gas. Then we have butane gas sensor. So there are different sensors to detect different gases. But they all work in the same manner. The moment that gas is present around it, it will give a high signal. But different sensors are there. Okay. Yeah, now there is one more question that is coming up. They're asking like, will we be able to explain ESP8266 board? Of course, madam, this is there in the syllabus. We are going to cover ESP8266 board. Okay, we are going to explain to you about the NodeMCU, which is a ESP8266 microcontroller. We will be coming to that. We will be definitely coming to that. Now, considering the audience for whom we all are from computer science background, giving an introduction to microcontrollers was important, so we have covered this. Now we will be starting with Arduino, and then after that we are going to do NodeMCU, and NodeMCU is an ESP8266 board. It's an ESP8266 board. We will be doing that. Okay. So I'll just proceed. We have only 45 minutes left. A lot of things to be covered in today's. I'll just zoom through this. Remember that what is an Arduino? An Arduino is not a microcontroller. Arduino is not a microcontroller. First thing, it is only a prototyping board. Why it is called as a prototyping board? It is because it is only for developers like you and me. If I want to develop some application, I cannot actually take a microcontroller like this. I cannot actually take a microcontroller like this, okay, like this, and I can start soldering my sensors to it or actuators to it. It's not possible to solder my sensors to a chip like this, okay? So that's why a company thought that we will develop a prototyping board where we will give header pins like this so that it becomes easy for developers and programmers to connect their sensors and actuators and develop their prototype first. And if everything works properly, then they can remove this Arduino board and put it into their PCB and start working it. So remember, Arduino is a prototyping board which will help developers to develop their prototypes, understand the concept, finish their application, then finally take that microcontroller and start developing the PCB, okay? And the microcontroller which is there on the Arduino board is an Atmega, okay? Atmega 328, to be very specific. Arduino is developed by an Italian company. There are different flavors of Arduino. You have Arduino Uno, you have Arduino Nano, you have Arduino Mini, then you have Mega. A lot of microcontrollers are there in Arduino again. I'm talking about the prototyping board. It depends upon how much power you require, okay? Some cases you require only few IO pins, GPIO pins. So you go for a Mini. A little more, then you go for Nano. If you need to connect a lot of sensors and actuators, then you go for Arduino Uno. And then you say, no, this is not sufficient. I need a board which has got a lot of GPIO pins to which I can connect a lot of sensors and actuators. Then you go for Arduino Mega. Okay, Arduino Mega. There are specifications available on the internet of how many GPIO pins it has got and all that. Okay, so what is an Arduino? It is a prototyping board which uses Atmega series of microcontrollers. And then there are some specifications here. I don't know. Okay, so when I click on that, yeah, so there are some specifications of the Arduino. The clock speed is 16 megahertz, operating voltage is 5 volts, maximum power supply is 20 analog pins. It has got 6 digital pins. It has got 14. When it says it has got digital input output pins is 14, it means that I can connect 14 actuators and sensors. Okay, not more than that. So these are some specifications of Arduino. Let us not go into too much of detail. Next is the Arduino programming style, how to write the programs in Arduino. How to write the programs in Arduino. Remember, the programming language is embedded C. Embedded C. The program structure is like this. Whenever we write a program in Arduino, we always write two functions, a setup function and a loop function. We write a setup function and a loop function. So what do we do in the setup function? Anything that you want to execute only once, when the microcontroller is powered up, we write it into the setup function. Whatever you want to execute only once, okay, when the power is given to the microcontroller, you write all that code into the setup function. And then whatever you want to execute continuously, as long as the microcontroller is kept on, we write that into the loop function. Anything that you want to execute only once is in the setup function. Whatever you want to execute continuously, as long as the microcontroller is kept on, we put that into the loop function. Two functions are there. It doesn't mean that you cannot write your own function. You can write your own user-defined function, of course, but these two functions are standard functions. You cannot have your own function called as setup and then write some code into it. It is already there. Loop function is already there. You have to understand when will these functions be executed. The loop function will execute continuously as long as the microcontroller is switched on. Setup function execute only once when you start, every time you start the microcontroller. Next, some of the built-in functions that we use, for programming the Arduino. The first, very commonly used, okay, these are some of the commonly used Arduino. Pin mode, okay, pin mode function is used to, I told you, initialize pins as input or output. For that we use this function, pin mode, P-I-N-M-O-D-E. P is small, M is capital. So this is the name of the function. Using this function, what we do is we tell which pin we are using and as for what, input or output. Then digital write. What is the syntax? It takes two things. Digital write, pin number, what you want to put on it, a high signal or a low signal. So we write digital write 8, high means I want to put a high signal on pin number 8. So the name of the function is digital write, D small, W capital. Okay, all that. Then you have digital read. Digital read is a function which we use for reading the status of a pin, whether it is high right now or whether it is low right now. We do that using digital read. Then we have a delay function which will cause a delay of so many milliseconds. Okay, 1000 milliseconds is equals to 1 second. 5000 milliseconds is equals to 5 seconds, and so on. Okay, what we need to program an Arduino? First of all, we need IDE. Arduino IDE we require. Arduino IDE we require to type your program, and then you require Arduino drivers. Okay, so demo. Time for the demo. Okay. I want to write my first program. My first program, I will write it here now. So I have a folder called as IoT, then I have code here, UnoBlink. Okay, this is the software which is required in your laptop. It is called as an Arduino IDE. It will allow you to type your program. It will allow you to change or convert your program from C to hex. And this will also help you to upload the program into the microcontroller. Simple. So what all it will give you? 3 options. It will allow you to type your program. It will allow you to convert your program from C to hex. And then finally, it will also allow you to upload the program into the microcontroller. Okay, just give me 1 minute so that I can arrange the camera here. Right now, I think you people are able to see my screen. I will start the video. The video is started. I don't know if you are able to see the video. Okay, so while you can see a small screen on the top there, if you click on that, that becomes maximized, so you can see the video zoom and the code is shared on the screen and so on. First, let us understand the code here. I told you there are 2 functions in the code always. In Arduino, there is a setup function. And then what I write in the setup function is I want to initialize which pin I'm using it for what. So I'm using this function called as pin mode. I say pin mode, pin number 7. I'm going to use it as an output pin. And then the loop function. What does the loop function does? It will put a high signal on pin number 7, then cause a delay of 1 second, then put a low signal on pin number 7, cause a delay of 1 second, and then this will continue forever. I told you that setup function execute only once when you power up the microcontroller, and the loop function continuously executes as long as the microcontroller is kept on, power is supplied to it. So it puts a high signal, LED will blink, then it will go off. LED will blink and then go off. So this will continue forever as long as the microcontroller is on. Okay, now I'll do the connections here. So what I have here is so I'm going to connect this microcontroller to my computer, and then I will upload the code. To upload the code, what I do is there is a button on the top here in the IDE only. If you just click on that button, this one, it will compile the code. It will check for syntax errors. If there are no syntax errors found, then it will convert this code into hex, and then it will upload it to the microcontroller. I need to connect the microcontroller to my laptop. I have to connect the microcontroller to the laptop to upload the code. So I use a USB. So I use this USB here. Okay, so I use this USB here like this. This goes into the USB of that, and then this I connected to the USB of my laptop. I connect this to the USB of my laptop. And I will now upload the code. Before I upload the code, I need to check to which COM port my Arduino is connected. So I just go to device manager, DEVICE device manager, and then I have to check here to which port it is connected. It is connected to COM8. It is connected to COM8. Okay, I know that. So I go to my Arduino IDE. I type my program. After I have typed my program, I go to Tools. I select which board it is. I know that this is Arduino Uno, so I select it from the tools, Arduino Uno. To which port it is connected? It is connected to port number 8. So I clicked on port number 8 in my Arduino IDE. And then finally, I click on this to upload the code. So when I click on that button there, you can see here down that is compiling the sketch. And then after some time it will say uploading. I don't know whether you're able to see this, but it says uploading, and then it says done uploading. Okay, so it has done uploading my code. That's it. Only one click of a button into Arduino IDE will do all those things. It will compile, it will convert it to hex, and then it will even upload it to the Arduino. Now you can see here that nothing is happening because I have still not connected. Now my program has started running. Please remember that my program, after I upload it into the microcontroller, it has started running. Okay, but I need to check it. So that's why what I do is I connect my LED now. Okay, so my LED is over here. Okay, so that is a LED there. My friend Vijay sir is going to help me out with this. So he's going to connect the positive leg of the LED, that is red cable, to pin number 7, and the negative. Yeah, he's connected to pin number 7. That's correct. It takes a little. Okay, and the other one he's connecting to ground pin. Okay, the ground pin. And then I don't know whether you are able to see this, but you can see that the LED has started blinking. Okay, what is happening is it is putting a high signal on pin number 7 for 1 second, and then it is putting a low signal on pin number 7 for the next second, and so on. And since the loop function is executing continuously, you can see that the LED is having a blinking. It is blinking. Okay, so I think a simple program of only 4 lines, we can cause a blinky program. Now, we will go further, and then I'll just give you an introduction to the NodeMCU, what is it and what type of programs to write. So I will close this program from here. Let us go back to part 2. Yeah, this is part 2, so let's start to figure out this. Okay, so I think we can stop the Okay, so we have explained to you what is a microcontroller. We showed to you how to write the code and how to upload it to the microcontroller Uno. We connected an LED. If you would have connected a buzzer instead of the LED, you could have seen that it starts making sound for 1 second, and the next second it is off. Then again it starts making sound for 1 second, and then again. So that continues in a loop forever as long as you keep the microcontroller on. Okay, as long as you keep the Arduino on, that is what will happen. So that is about Arduino. Okay, it is an Arduino board. If I would have brought a gas sensor, connected it to pin number 2, and then the same application which we did, the same application that we wrote while I was telling to you people what is the meaning of a microcontroller. If I would have connected a gas sensor to any one of the pins of the Arduino, and then a buzzer to any one of the pins of the Arduino, then I could have written a program to actually show you that if there is leakage of gas, it will start making sound. That could have done, but Since it was a little complicated to do it, I said we will do only with the Blinky program. Okay. Now let us go further now that we have understood the meaning of a microcontroller, we will go further and understand the next. The question was asked, no, are we going to do ESP8266? ESP8266 is, of course, a very, very powerful compared to Arduino. Now, first you have to understand what is this NodeMCU. How is it different from the Arduino Uno, which we discussed before this? NodeMCU is also a microcontroller. In the sense, it's a prototyping board. It's a prototyping board on which there is a microcontroller, And you know by now what is the meaning of a microcontroller. You can write a program and you can execute it forever as long as the microcontroller is kept on. As long as the microcontroller is kept on, the program will start running, whatever you write in the loop. NodeMCU, the only difference between a NodeMCU microcontroller and the Arduino Uno is that NodeMCU has got Wi-Fi capabilities. Okay, it has a Wi-Fi antenna on top of it, and the Wi-Fi antenna gives it a Wi-Fi capabilities, which means that you can make a NodeMCU connect to a hotspot or an access point of your house, or the NodeMCU can actually create its own hotspot so that you can connect to that hotspot and so on. It depends upon what type of an application you are writing. But let me tell you that a NodeMCU has got Wi-Fi capabilities. It can connect to an access point, or it can create its own access point, depending what you are doing. It depends upon what you are doing and what code you write into the NodeMCU. Now you will ask me a question. So then in that case, what is the programming style of NodeMCU? NodeMCU, Arduino Mega, Arduino Uno, they all follow the same programming style which I showed you. It contains two functions, setup function and loop function. Setup function executes only once, and loop function executes continuously as long as the NodeMCU is kept on. So all these microcontrollers have got the same programming style, okay, setup function and loop function. So I will just give you introduction to NodeMCU today, and then the demonstration as to what we have done, what we will be doing tomorrow. This I will just show you today, a little glimpse of what we'll be doing tomorrow, and then tomorrow I will be explaining you the code. Okay, so tomorrow we have the last day. We have 2 hours tomorrow. Very quickly, I'll just finish what is there in this PPT right now.
With a national
Okay, so there is a little power failure here. Hello. There is a little power failure here. We are getting back to the battery once again. Okay, so I think the screen is back. Now I told you about NodeMCU. The only difference between a NodeMCU and a simple Arduino is that an Arduino doesn't have Wi-Fi capabilities. Arduino Uno, NodeMCU has got Wi-Fi capabilities, and it has got the same thing. It has got GPIO pins to which you can connect your sensors, you can connect your actuators, okay, and then you can connect any type of a sensor to the NodeMCU. Okay. The only thing is that it has got Wi-Fi capabilities. This is 8266 microcontroller. Remember, this ESP8266 microcontroller has got Wi-Fi capabilities. You do the connections in the same way, you write the programs in the same way, you use the same functions, pin mode, digital write, digital read, delay, same functions you write. In fact, you use the same IDE. You have to use the same Arduino IDE to write your programs for the NodeMCU also. But only thing, when you want to upload the code, you have to select from the tools which board you are using, and from there you have to select NodeMCU, and then you have to click on the upload button. It will start uploading it to the microcontroller. Okay. Now the features of NodeMCU very quickly. It's a microcontroller with Wi-Fi capabilities. It has got digital and analog pins to connect sensors and actuators. It uses the ESP8266 chip. Same programming style as Arduino, which I have already told you in the previous slide. Now developing a sensor node. Next thing is, we actually finished today's session a little early. This is only the glimpse of what we're going to do tomorrow. What we will be developing is, in the tomorrow's session, we are going to write programs for the NodeMCU using the NodeMCU, the DHT11 an LDR sensor. We're going to use DHT11 LDR sensor, okay, and we will be developing a sensor node. Okay, now this is a project that was given to us by our sister concern. We have a dental college, a PDS college in Belgavi, called as Marathimandal Dental College. They have a research laboratory there which develops medicines. There is a PG R&D Center for Pharmacology. What they do in this lab is they make a lot of medicines and all that, and they have to test these medicines on specimens, like some animals they use. They use white mice, they use white rats, rabbits, guinea pigs. They use a lot of animals there, and there is a special animal house. There is a special animal house. We visited there, and then what they said is that these animals has to be kept in at very comfort. The temperature has to be properly maintained, the humidity has to be maintained, the light intensity in the animal house has to be maintained. They take all these parameters into consideration, and then they inject these animals with the medicine, and they study the effect of this medicine on the animals. So when we visited there, we saw that the animals were kept very comfortably. There were ACs, there were humidifiers to maintain the humidity, dim lights were there, all that were there. And then we saw that there was a register there. One person was actually going and checking what is the temperature, and he was recording it into the register. At 10 o'clock, the temperature was so and so, the humidity was so and so, and the light intensity was so and so. So he was actually doing it manually. And then it was instructed to this person that he has to take these readings after every 15 minutes. He started doing it. For the first day, he did it after every 15 minutes. Next day, he started taking the readings after every half an hour. And then now today's case is that he takes only once a day. The problem is that when you have a monotonous job, something which has to be done same continuously for a long time, these type of things can be automated. You don't require human intervention. And then suddenly we took it up as a problem, and then we provided a solution for that. We provided it as a solution. What we did was we developed a sensor node for them, packed it in a good box. Okay, we connected two sensors to it. We connected a DHT11. We connected a DHT11. DHT11, by the way, is a sensor which will detect your current temperature and humidity. It is capable of, it is actually capable of determining what is the current temperature and humidity. Okay, and then we used an LDR. LDR is a light dependent resistor, which is normally used for checking how much intensity of light is there. Okay, what is the intensity of light? It checks that, and then we can calculate light in terms of lux. Light is measured in terms of lux, so we were able to actually convert this to lux. And then finally, this data was going to the cloud server, and it was getting stored there, so that the people who are actually working on the experiments, they wanted to see what is the temperature in this laboratory. Okay, all the time they wanted to generate a report. All this time they were actually going through the register which the person was writing, and then they were generating the reports from there. What we did was we developed a front end for them, and we gave it to them, and we told them that you can actually use this front end to generate your report and see on a particular day how much was the temperature, at a particular time how much was the temperature. All that we gave it to them, and then they were very, very happy. And then I would just wanted to show you how does the box actually look like. One second, let me just start the video. And then, yeah, you can see this is how the box looks like. And then these people were actually so happy looking at the sensor node. They asked us how much does it cost and all that. And then, then we thought that there is a lot of potential for these type of products. The person who is actually working there in the laboratory, he said that these are into too much of demand. Every laboratory will have an animal house. And not only in the animal house, so many places will be there in the laboratory where temperature, humidity has to be properly monitored. And then we developed this small box here. I don't know whether you were able to see this or not. It is a 4-inch by 4-inch box in which we have connected the DHT11 sensor here. Okay, and then we have the light sensor here. We have the light sensor here, which will detect the light. And then it has got power supply. It has got power supply. This is where you connect the power supply directly. You have to supply 230 volts using a simple cable. and then keep this, just keep this wherever you want to monitor the temperature, humidity, and the light sensor. Okay. We developed this and then we demonstrated this. The output also was coming in very nice. Now I wanted to demonstrate this to you people first. So we have another, yeah, we have 10 minutes. So what I will do right now is I will connect this to one of the power supplies here. And then I would want you to browse, to go to a page. I will send you the link in the chat. Click on that link, open the browser, and then you will be able to see the data that it is recording. You will be able to actually see, you will be able to see the data that it is recording in real time. Okay, and then tomorrow we will be understanding the code that we have written into this. Okay, the code that we have written into this, that we will understand. That we will do it tomorrow. So this is the box. I will set it up now. We will connect this to the power supply. And before that, let me show you. I have another box like that because they wanted these boxes to be kept in two places in the laboratory. So this is the box which I have opened right now. This is another box which I have opened right now. What it contains, what it has is nothing much. There is only a NodeMCU microcontroller connected to the sensor here. And then it has got a power supply, 5-volt power supply. It has got 5-volt power supply. That's it. Nothing, absolutely nothing more than that. Sensors connected to the microphone. Tomorrow I will be discussing with you about the connections also. Okay. So now I will power it up. And then I will share with you people the URL that I want you people to go and then browse. Okay, just give me 1 second. Okay, so we have connected the device. We have connected the device to the power. Okay, and then you can see that small LED also over there. Now, what I want you to do is, in the chat, I will send it for everybody. Let us see if it is possible in the chat. I will. Yeah, I'll send it to everyone. Okay. Yeah, I've sent a link to you people in the chat. Okay, it says myspace.belgamonline.com/ah/ah. Okay, if you click on that, if you are on the mobile phone, the browser will open up. If you are on the laptop, here also you need to just copy that and paste it into the browser. Okay, and then it will show you Animal House monitoring system. Enter the user ID as admin and the password as admin. User ID as admin and password as admin. And click on login. So when you click on login, you will be able to see the data, you'll be able to see the data. Oh, yeah. So you can see that there is this data that is getting recorded now. Okay. And then you need to keep refreshing, because you know what we have done it in such a way that the code is written in such a way that it determines the current temperature and humidity and the light intensity after every 5 seconds, and then it puts it into the cloud server. Okay, after every 5 seconds, it puts the data into the cloud server. So right now, totally 22 entries already. 22 entries already. You can see the temperature, current temperature of where I'm sitting is 26, humidity is 78, and the light intensity is 29. Light intensity is 29. So again, if I refresh on this, 24 entries already. 26, and humidity will remain 27 because there is no change in the humidity and temperature. Light intensity is 28. Now what I will do is I will keep my finger over the light sensor so that I can make it dark. Okay. Now I am keeping my finger on the light sensor so that absolutely there is no light falling on the light sensor. And then I think it must have taken some readings now and put it on the cloud server. So I will refresh this. And you can see that the light has come down drastically. From 28, it has become 4, and then 3, and then 4 again. Okay, I will refresh this again. Let us see. Yeah, 1 and 1.8 also completely covered. I will remove my finger now from the light sensor. I will refresh this, and then now you can see that the latest value is 29.78. That is light intensity. Okay. So the sensor node is kept here in my place where I am sitting. And then wherever you people are, you are actually able to see the readings now. So like this, I can keep this sensor nodes wherever I want to monitor light, temperature, moisture, whether a motor is switched on or it is switched off. I can basically have any type of a sensor connected to my sensor node, and I can monitor this from anywhere in the world. If I send this URL to my friend in USA, now even he will be able to see what is the current temperature and humidity and light intensity of the room in which I am sitting. Okay, so this is only monitoring. Okay, this is only monitoring. Tomorrow we will be doing an example on controlling. Tomorrow we will be doing an example on controlling appliances. Now I will share with you people one URL where there is a button. If you click on that button, here the LED will be switched on. If you click on the off, the LED will be switched off here. So that is what we will be attempting tomorrow. Okay, so this is only for monitoring. Now see, as long as I'm keeping my sensor node on, so now already 45 entries now. Continuously that sensor node is determining temperature, humidity, and then putting it into the cloud server, which I'm able to actually see it. And then now these people actually wanted that the reports should be generated based on time and date. So you can select from, if you want to know what is the temperature and humidity from a particular date.
Yes, I will take it as yes.
You can select even that.
I will take it as. And it is equally important we need to justify.
Okay, so now we will stop today's session. We are open now for the questions. Okay, we are open for the questions now. Tomorrow, what I will do is, tomorrow I will be explaining to you the code that we have written for the sensor node. What code we have written for the sensor node, that we will understand tomorrow. And then we will also understand how to control. I'm going to explain to you step by step, like how I explained to you people about the Blinky program for Arduino. Similarly, I'm going to explain to you people what code I've written for the sensor node here. Okay, I'm actually letting my confidentiality out to you people, but I think it is worth it. No problem. Okay, so we are open now for the questions. There's a question that is asked here. How many GPIOs we can connect to NodeMCU? Okay. Now there is a question that madam is asking, like how many GPIOs does a NodeMCU has, and how many sensors or actuators we can connect. Now, if you are able to see my screen here, in this is the pin diagram of a NodeMCU, and this is the pin diagram of a NodeMCU. The NodeMCU has got, so wherever you see this GPIO, there is GPIO pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13. So 13 altogether. 13, you have 13 GPIO pins, so you can connect 13 sensors or 13 actuators to your NodeMCU. Absolutely no problem. Do you have any other questions? Okay, now there's another question where sir is asking what is the difference between DHT11 and DHT22. DHT11 and DHT22 are both temperature and humidity sensors. DHT11 and DHT22. DHT22 being more accurate. DHT11 is not all that accurate. Not in the sense the tolerance is only 1.5 degrees. For example, if the actual temperature is 26, okay, DHT11 can tell you that it is 27.5 or 24.5. Okay, so there is a tolerance of 1.5 degrees in DHT11. DHT22 is highly accurate. Okay, if it is 26, there is a tolerance, there is a error margin of only 0.5 degrees Celsius. Only 0.5 degree Celsius. So DHT22 is more accurate. 11 is not very accurate. And the cost wise also, DHT22 is a little expensive. I think the cost of DHT22 is something like 350 or 400 rupees, whereas DHT11 you will get for 100 rupees. DHT11 you will get for 100 rupees also. 22 is 350 or even 400 rupees. One more question that is there is of home automation. For home automation, how many NodeMCUs we require? Now, this is a good question. The question that is being asked is like, if I want to do home automation, how many NodeMCUs do I need? See, finally, it depends upon how many GPIO pins you have. I told you that it has got 13 GPIO pins, which means that you can connect 13 appliances. So if your house has got only 13 appliances, then you require only one NodeMCU. If the number of appliances increase, then you will need more NodeMCUs. Okay, you will need more NodeMCUs. But then again, using only a single NodeMCU, you can connect more than 13. There are techniques to do it, using a multiplexer and all that. There are techniques to do it. I cannot immediately tell you that for home automation you require 4 or 5 like that. It completely depends upon how many appliances you want to control. Another question is, वीरेंद्र शर्मा सर यहाँ पे पूछते हैं कि पासवर्ड में क्या फिल करें? अच्छा, ये आप इसकी बात करें. ऑनलाइन में you have to enter the user ID as admin and the password as admin, ADMIN, admin and admin. User ID and password is admin and admin. Then you will be able to see that interface. Okay, you will be able to see that form. Okay, first it will ask you for. So when you are taken to this form here, you have to enter admin as the user ID and the password is also admin, ADMIN. Then when you click on login, it will take you to the next page where it will show you all the readings that it has done so far. So you can see that already there are some 52 readings that it has already taken, because it is very frequent. It is happening after every 5 seconds. We don't want it so frequently to happen. This has to happen after every 15 minutes. Absolutely no problem. We can even do that. So we will be understanding this code tomorrow. We will be definitely understanding this code tomorrow, what code we have written and all that.
Hello.
Hello. Yes, madam. Yes.
Hello, Navid sir.
Yes.
This is Swati here from Bangalore. Sir, my nephew is created one RC robot car by using your Arduino board, and he has used the sensors and motors in it.
Okay.
And he is unable to operate it. The motor is rotating only the left side. He wanted to operate it backward, front, left, and right. So it is moving only to the front side, forward moving, no backward, and there is no motion between the backward and right and left. It should turn, the motor should turn the right and left. So can you tell me the code, how we can write it?
Okay. Now, good question. What madam is trying to ask is that they have developed a small robot which has got wheels, and then which moves only in the forward direction. They want it to move in the backward direction, as well as it has to take a left turn and a right turn. Now, madam, I may not be able to give you the code immediately, or because it takes a little time and all that, but I will tell you the logic. It's very simple. Now, see, for the tires, for the wheels to move in the forward direction, for the wheels to move in the forward direction, you have to rotate the shaft in the clockwise direction. Okay, when you, and of course you will use something called as disturbance. Okay, so what I was telling is, to rotate a wheel for a robot, you need DC motors. DC motors has got two terminals, positive and negative, or you can say A and B. There is nothing called as positive and negative in a DC motor. When you apply the positive of the power supply to one of the terminals and negative to another terminal, it will start rotating clockwise, let us say. When you reverse the polarities, when you change the wires, okay, connect the negative to the other terminal and the positive to the other terminal, it will start rotating in the clockwise and anti-clockwise direction. Now remember that DC motors are used for robots. DC motors has got two terminals. When you connect the terminals, they will start rotating clockwise or anti-clockwise. When you reverse the wires and connect it to the motor, they will start rotating in the anti-clockwise direction. For rotating or to, and of course, see, when you have clockwise rotation of the shaft, it will move in the forward direction. When you have anti-clockwise rotation of the shaft, it moves in the backward direction. Okay, basically this is the concept used for forward motion and backward motion. Here you have to use something called as motor driving ICs. Okay, there are ICs like ULN and all that. You will have to definitely use that to rotate into your desired rotation, either clockwise or anti-clockwise. Okay, only supplying power from the Arduino will not help. You will require an extra circuitry for that. To rotate, to move the robot in the forward or backward direction. And the extra circuitry is motor driving shields. They are called as, if he, your cousin or whoever, your nephew, whoever it is, if he is using Arduino, then you will get something called as an Arduino shield for rotating motors. He has to use that. Code is very simple, absolutely simple, but an extra hardware is required. I don't know whether he's using those shields or no. Shield is those motor driving shields, that's it.
Actually, sir, he is using the Bluetooth controller, serial controller, Arduino board, and the sensors to detect the object. Whatever the object comes in the path of the robot, it is detecting that particular object. Only the thing is that the clockwise and the anti-clockwise, the movement is not happening in that particular robot.
Okay, now
so
see,
that's why
he's using Bluetooth for controlling, for giving instructions to the robot. Okay, if you click on the forward button here in the mobile phone using Bluetooth, that instruction goes to the robot. If you click on the backward button in the Android phone, then you are giving instruction to the robot to move in the backward direction. So Bluetooth is used as an interface for communication from the mobile to the robot. Next,
Yes, sir.
sensors are used for finding obstacles. If there's an obstacle, it has to stop. So sensors are used for that. Now, the problem is that to move it in the forward or the backward direction, you have to control the rotation of the shaft, the rotation of the DC motors. And to control the rotation of the DC motors, you require motor controlling or motor driving shield, which has to be put. I am definitely sure he is definitely using that shield. Otherwise, you cannot directly drive a DC motor from Arduino GPIO pins. It's not possible. You have to use a shield. He must be using it. Okay, so he has to use that shield, write the appropriate code. It is a little lengthy to explain here, but an extra hardware is required. That is the motor driving shield. That you please remember.
Okay, thank you, sir.
Okay. Another question here, they're asking what is the actual difference between a gateway and a cloud. Okay, gateway and a cloud. I told you that the communication model that has to be used is either device to device or device to gateway or device to cloud. If I'm using the model of device to directly from a device to the cloud, okay, I require a global IP address to be assigned to the sensor node. Okay, but if it is a gateway, then multiple devices can connect to the gateway, and from there the information can be put into the cloud. For a cloud architecture, each device is connected to the cloud. They need to be having their own global IP address. Whereas if it is for a gateway, then the gateway will have a global IP address. Devices will connect to the gateway. So this is more cheaper. I don't have to have so many IP addresses. For example, let us say I have in my college campus here, I want to monitor the temperature in different departments. So I keep one sensor node in, let us say, in the mechanical department, one more sensor node in the computer science department, and so on. I keep different sensor nodes into different departments. Now I don't need these devices to connect all of them separately to the cloud. I make one gateway in the center of the college somewhere, and I make these devices to connect to the gateway, and the gateway will be taking the data from each one of these sensor nodes and putting it into the cloud server. That is what we have used for this animal house, animal temperature humidity monitoring system. That is what we are using here. Okay, we have a gateway in the center, and there are multiple such sensor nodes which we are keeping it into different rooms. In one of the rooms, there are dogs kept there in the animal house. In another room, there are white mice, guinea pigs are there. In different rooms, they are there, and they want to monitor temperature and humidity from these different places. So we have made a sensor nodes which gets connected to a common gateway, and from the gateway, then it goes to the cloud server. It is like that. So that's the reason why if you open this, you will be able to see that there is something called as node number here. Node is 2. Node is 2 means this is some room number. Okay, the one which I had switched on right now, it was node 2. Node 2 was kept in the dog house. Node 1 was kept in the guinea pig house, and so on. It is like that. Okay, so that is the difference between a gateway and a cloud. Then another question is, using Arduino boards, can we go for commercial products like proximity, thermometers, etc.? If we cannot, then what type of microcontroller suits to develop Make in India products? Yeah, this is a good question here. Tanvir Alam sir is asking. Okay, now what he's asking is, can we use this prototyping boards like Arduino for developing products? Okay, for developing products, is it good to develop is using? See, prototyping boards and Arduino are not meant for developing commercial products. Now you must have seen the product that I developed for the animal house. Here there is NodeMCU. Even NodeMCU is not a good idea to be used in a product. Now since they wanted, it's a sister concern, we have used this. But if you want to develop a product that you want to mass produce and sell it in the market, your Arduinos will not help you. And it is not a good idea to use an Arduino. I told you that Arduino is a prototyping board, but the microcontroller which is there on top of the Arduino is Atmega 328P. So develop your prototype on Arduino. Then finally, you know that you have written the code for the Atmega. So remove the Atmega chip from there, create your own PCB, and you put your relays on the PCB if it is required for your product. Put different sensors if you require on your PCB and so on. If you're interested, then tomorrow I can actually get a PCB which I have developed for one of the products here, where we are keeping the Atmega 328 on which we are putting our relay and everything. So finally, when it comes to a finished product, it is not a good idea to use an Arduino. Rather, use the microcontroller, Atmega 328P, design your own PCB, pack it into your own enclosures, and then you can mass produce it. I think that's about it now. It's already 1 o'clock. So we will again meet tomorrow at 11 o'clock. So I told you tomorrow what we will be doing. We will be understanding NodeMCU coding part. Then we will be controlling this. And then I will be giving you introduction to what is a single board computer. So that's about it. Nothing much. Okay. Any more questions here? People are telling that the session was excellent and all that. Thank you so much for the good comments. Actually, this is what motivates all of us. We are teachers, and the biggest motivation a teacher gets is from these motivational messages. Jalaja madam, if it is over, then we can stop for today.
Yes, sir. Navid sir, thank you. Thank you so much.
Thank you, madam.
Yes, sir. Navid sir, can you hear me?
Yes, I'm able to hear. Tell me.
Yes, sir. Navid sir, thank you so much. We really had a very wonderful session. This session, participants kindly note that this session is going to be continued tomorrow at 11 o'clock. The group, the link will be shared 10 minutes before the session. Kindly join through the shared link. And thank you one and all for that.